So we're going to begin our unit today on trigonometry, and we're going to first start by reviewing just some of the concepts that we learned in Math 2. And so with trigonometry, we are really talking about what we call right triangle trig. And so with a right triangle, there are very specific characteristics to what we have in a right triangle. In your right triangle, you have a section or a little spot right here which makes a 90-degree angle. That is your right triangle. All right, so this is how we denote that we have a right triangle, is by using that little piece right here in the corner, and that's a specific 90-degree measurement. Now the sum of all of the angles on the inside are 180 degrees, and so that means if this is our 90, then the sum of the other two are the other 90. Now the two sides of the triangle that connect to form the right angle are called the legs, and the longest side, which is opposite of the right triangle, is always called the hypotenuse. And that's important so that way we know no matter which way we orient the triangle, we know which sides are which. So today what we want to focus on are a few key items. The first one is, what do I need to do if I want to find a missing side? And when we're trying to find a missing side of a right triangle, we've got two different options. Right? The first option is that it is possible that we might be able to use the Pythagorean theorem. Now the Pythagorean theorem, you must have two sides in a Pythagorean theorem, and you're going to use that to find the other side. And so that theorem is a squared plus b squared equals c squared, where the a and the b are the legs. And so it doesn't matter which one you call a and b. All right, I can call this side a, I can call this side b, but the a and the b are interchangeable depending on what you want to call a or b, but they're both a leg, and the hypotenuse is always side c. So no matter what, this is always the length of the hypotenuse. Now you have to remember that you are squaring each individual piece. Right? The other way to find a missing side is by using trig, which is SOHCAHTOA. And so you may remember this from Math 2, or you should remember from Math 2, a bit about SOHCAHTOA, but we're going to review it again. But the different letters in SOHCAHTOA refer to different trig and different ratios. So let's first start with just finding a missing side. So let's use the Pythagorean theorem. Let's say we have a triangle, looks like this. So again, I can orient this whichever way I want. I'm going to call this side 8, this side 15, and I want to find the unlabeled or the missing side. Right? And so again, because my right angle always points to my hypotenuse, I'm finding measure c. So let's set this up. C squared is equal to 8 squared plus 15 squared. And you're definitely going to need to use a calculator. And some things that you want to remember when you are doing these is that you have to always leave these as simplified radicals. And now that means that c squared is going to end up being 64 plus 225. And you can start seeing how this is you can start trying to skip some of these steps a little bit. But really, to be able to find the length of c, I have to take the square root of both sides. And so c is the square root of 289. Now I'm not really sure if that simplifies at all, but if I think about perfect squares, that's not a perfect square. Now you can look on your phone, you can look on a calculator, but that's not a perfect square. And so what I would have to do is I'd have to try to see if I could break that down, but I'm pretty sure that there's no way to break down 289 and take out perfect squares. And so that would be my final answer. I would have to leave it that large. If you are in a spot or you are doing some work where it says to round your answer, then we can do that. So one thing that you want to be able to do is you want to be able to make sure that you can always kind of read the directions and see what happens. Now, I'm going to check on my calculator real quick because I wasn't sure if I could break that down, and I was wrong. Right? That really is 17. And so really what I need to do is I need to change my answer. And again, I can check that on my calculator, 289, and I'm going to take the square root. Okay. And so I really should have labeled it this way. All right, I didn't think that was a perfect square. I really probably should have paid more attention and used my calculator to check it. And so that's one thing that sometimes we get in a bad habit of, is we see a really large number and we think, okay, that doesn't really seem familiar to me, so I'm just going to leave it alone, when I should have pulled out my calculator and tried that instead. And so it's a good thing that I checked, because really that means that side C over here I could label as 17. All right, so always check with your calculator. If you get a decimal, then you'll have to look at the rounding directions, or again, if you have to simplify. So let's look at another example, just one more, using the Pythagorean theorem. And so I'll just draw this triangle facing this way. And I'm going to label this side 25 and this side 15. Right? And so I'm going to be finding this missing leg. And I know it's a missing leg because, again, the right triangle points to c squared. So if I set this up, I'll be looking at a leg squared plus, I can just label this side b. It can be a or b, it doesn't matter. Plus b squared equals 25 squared. And now I need to solve for b squared first. So I need to first move over and subtract that 15 squared, because right now the only way I can move that is to subtract it from both sides. Right, so now I'm going to kind of check on my calculator. Let's see if I can do this. 25 times 25. All right, so that's 625. So 625 minus, and I know this one is 225. So again, I'm doing a lot more work than I need to, just to kind of show you the steps and remind you. But that really means that when I take the square root, right, b is the square root of 400, and if I check that on my calculator, I get 20. And so that's going to be my answer. All right, so using the Pythagorean theorem, we are able to find the missing length of any side of a right triangle as long as we know two of the other sides.